Okay, welcome back to this series of Project Euler codes. The next one that I'm going to tackle is even Fibonacci numbers, problem number 2. Problem number 2 states, each new term in the Fibonacci sequence is generated by adding the previous 2 terms. That is the Fibonacci sequence. By starting with 1 and 2, the first 10 terms will be, there we go. By considering the terms of the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. I'm going to create a snip of this so I can keep reading it. Open up my LabVIEW project, create a new VI here. I'm going to name it problem number 2. What is this one called? Even Fibonacci numbers. Even Fibonacci numbers. I think there's an extra space there. There we go. And the first thing I'm going to do is copy this prompt here so I can look at and see and remember what to do in each one. Okay, so in order to actually do this, I need to first create a little algorithm that will give me the first Fibonacci sequence numbers that do not exceed 4 million. So in order to do this, I'm going to use a while loop. I'm going to add a number here. This number is an I32. Okay, so that will be big enough because I only need to go to 4 million. So I'm going to create this number here. I'm going to create a shift register. And I'm actually going to pull this down. If you don't know in LabVIEW what this does, is it gives you the number that goes into here. Let me fill this out a little bit before I say more. What I'm going to do is I'm going to add the previous 2 numbers and feed it back into here. So what this does, a shift register makes the last number in the last iteration of this loop available at the beginning of the loop now. So it's kind of like a shift register that holds values. And you can see I can pull this down to get any number of previous shift register elements that I want. So this will be the last number that was put into the shift register. This will be the n-1, n-2, n-3. But since Fibonacci sequence is only the previous 2 numbers added together, then I only need 2 of these shift registers. So I'm going to add a 1 here. I'm going to create an in, because 1 is the first number in the Fibonacci sequence. And technically, this number should actually also be 0, even though the Fibonacci sequence does not include 0 plus 1. It starts at 1 for mathematical purposes, and for the computation, we kind of have to do it this way. So I'll call this current Fibonacci number. Oops. And I am going to look at this. Oh, I need for right now, just while I'm testing this, I'm going to leave this as false, so it'll just run forever. And I'm just going to watch this and make sure that this actually creates the Fibonacci sequence for me. So I'm going to run it. First number's 1, then 2, then 3, 5, 8, 13, 21. Okay, so that is actually creating the first, or the Fibonacci sequence. So then the next thing that I need to do is, what does it actually specify? It says values, by considering the terms in the Fibonacci sequence whose values do not exceed 4 million. So as long as this number is less than or equal, wrong one there, oops, to 4 million, then I want this to be true. And actually I need to not this, because I want it to keep going as long as this is false. So I've created this logic to end the loop once the current Fibonacci number gets over 4 million. Now the last thing I need to do is take this number and create an array. So I'm going to put this tunnel mode indexing, and I'm going to create a conditional here. Whoops. So that as long as this is true, I will index the number. Actually, let me go back. So if we just run this, it should give me a number that's over 4 million because I'm still including the current Fibonacci number. This is the first one that is over 4 million, which it looks like, that's right, 5.7 million. So now what I'm going to do is I'm going to take this number, make it indexing, like I was doing before, tunnel mode, conditional, tunnel mode, indexing, so it's an array, get rid of that. And what this should give me, indicator, and I'm going to put, again, as long as this is true, so the first iteration that this is no longer true, which is the very last iteration of this loop, that number won't be included. So I should be able to run this. and come up with an array. Again, I don't know. I have no idea how long this is actually going to be. Less than 100 elements, I would say. 50? Oh, less than 40? Okay, it's not very long at all. So I'm going to add all these numbers. Okay, and let's see. Yeah, the last iteration is the first number in the sequence that is below 4 million. So we know that this number is the last one in the array below 4 million. The current Fibonacci number is above 4 million. And so we know that we've got all the elements in the array of the Fibonacci sequence. Now the next thing we need to do, by considering the terms of Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. So the next thing we need to do is determine if which of the numbers in this array are actually even valued. In order to do that, I'm going to take a very brute force approach. I'm going to take this array, feed it into the for loop. I'm going to use the, numeric, the quotient and remainder. And I'm going to divide this by 2. What this does is it does division, but it gives me the quotient and the remainder separately, so I can check to see if the remainder is anything other than 0. Made a mistake here. I want to create a constant. That should be 2. Let's over a little bit. And I want to check equal to 0. If this remainder is equal to 0, I am going to concatenate this array, or these numbers, so it is an array. I'm going to add the conditional, done mode, conditional. And as long as this number is 0, then that is an even number, and I'm going to add it to this array. So this first array here is going to be Fibonacci sequence, and this is even Fibonacci numbers. And I'm going to run this next. And if we look here, let's double check it. This should be a bunch of just even numbers. Yep, and you can see that there are not many. The last thing I have to do is just add all of these terms together. And to do that, I'm going to use the add array elements. And I am going to add every element in this array, create an indicator. I'm going to call that even Fibonacci sum. And I'm going to run this again. And that number is what? 4.6 million, roughly? Yep, 4.613 million. So I'm going to check that against my random solution guide that I found on GitHub, and we can see very clearly here, 4613732. 4613732. So I am going to assume that we did this right, since we both got the same number, and run over this code again. So the first thing that we did is we created a Fibonacci sequence by just computing the algorithm of the previous 2 iterations of the sum, and made sure that we only added the elements to the array, to this array of Fibonacci sequence as long as that number was below 4 million. Then we simply went through that array and computed all of the even numbers that were in that array, and then we added them all together to get the even Fibonacci sum. Hope you enjoy this. Stick around for the next video, problem number 3.